Rinat is working as a project lead at BMW Group. I don't have to introduce BMW, you all know. His former position, he was a software architect and electronics specialist. And he is involved in architectural development in powertrains and the Autosar rollout for BMW, including the process and the methodologies. In his current position, he is the driver of the Autosar consortium on behalf of BMW. So he's literally our Autosar man. And I'm really looking forward to it. Besides all these beautiful, amazing professional experiences, the reason I admire Rinat is you're really passionate about Autosar.
Absolutely.
Absolutely, you love Autosar, and this is something really admiring. So, ladies and gentlemen, big hand for Rinat Asmus.
Thanks for having me today. You talked about communities. There's one community which was established in 2003 that where BMW was kind of main driver to say we don't want to build systems from the start. We have to reuse things. We have to create a good ecosystem around our EE architectures. And with that, I think a lot of responsibility came up and a lot of technologies we already included in this standard. And I think for the future, the challenges, what you also mentioned, is definitely not less interesting for us. So let's take the German phrase, a little bit defensive on that. So we have to be conscious about what we really would like to drive in automated driving, for example. And therefore, I would like to give you a snapshot on Autosar. Autosar is not an usual standardization organization. It's more the industrialization of a standard. So what we usually do is we kind of use an ISO standard or something that is really demanded by more than one OEM and put that to the series projects. We sometimes have life cycle times up to half a year. So it means we need to be present with the requirements, and half a year later, we get the same stuff from the standard to the series. This gives us a lot of pressure in the standard and also in the collaboration with the core partners. The real benefit is that we kind of bound suppliers and the OEMs in one community. The core partners, which are huge companies, also are driving this project, and we try to really create this ecosystem for us that we have the right suppliers in the right place, in the right time, and the important thing is with the right technology. So we early take the chance to go to the standard and say, for example, save time is something very important for us for automated driving. We don't need only a time base for Ethernet. It must be also safe and secure. Next step is secure. We just start with safe. So this is the way we approach it, and then our suppliers are in the same ecosystem and we can directly start with series development. This is the real benefit out of it, and you don't have to wait longer times for bigger standards, as you know, to set it up in different countries and so on. So this is somehow the background. We have 280 partners at the moment. It's split to the core partners on the left side. We have strong commitment from premium partners from the middle part. And of course, development partners, smaller companies with dedicated topics where they're really interested in. Also Matrickz is mentioned here on the right side. And we have the associate partners that are simply using the standard. To the round, who knows Autosar? Because I won't go deeper on the organization. Okay, so I think that's the bigger part. We can also have a short chat after that. I think like 4 or 5 years ago, there was a big challenge to ask ourselves what's the next step. Classic platform was kind of established. A lot of suppliers provided that. We had 60 to 80 ECUs running on that in the cars, and we were pretty happy, right? But at one point in time, you ask yourself, what's the next challenge? And we saw definitely in the topic of security, safety, reliability, a next step, but also a lot of challenges with regards to vehicle to X and big data to handle that. So classic platform would not make it per architecture. New architectures, really like technical architectures, new processor architectures, GPUs that are really bound to onboard systems now, are creating for us a new challenge. And there the adaptive platform was for us the concrete answer. We had from the right side also infotainment systems, Linux-based systems. We did a kind of study group in Autosar and invented something in the middle. We at least have an ASIL B running for this. And on the left side, you see the classic platform. As I said, it's certified up to ASIL D by several suppliers. And the adaptive platform, we see that right now in first automated driving use cases is an accomplishment to the whole system, which means you don't build a safe system out of nothing, and not only with a classic platform. You need something with computing power. There we add the adaptive platform, and if they work in parallel or maybe in with a better architecture, you can address these requirements for automated driving easily. Not easily, but it's working. For us, it was the next step, and the real requirements, also of course, the classic platform is not outdated. If you adopt a feature in the system like IPsec, we have a new protocol coming in for the next release, it must work in the whole system. So we address the same requirements for the adaptive platform as for the classic platform, and we connect them together as the information which are service or signal-based oriented can flow from platform to platform. This is how a usual setup looks like. We have non-Autosar systems inside of the car. On the other side, you have the adaptive platform, which is in the direction of body domain with gateway functionalities. You can connect vehicle to X use cases to this. It's Ethernet connected, and of course the classic platform provides you with more safety related information, which are also approved from tool vendors and other suppliers. The main benefit of standards is just one sentence to that, because we can have another talk on this topic. The reusability of application software, that you don't create architecture over and over again. The same platform shall be used at least 3 lifetimes. If you start to do your platform from the scratch in the next project, you should ask yourself if you're driving the right platform, from my perspective. And the adaptive platform itself is somehow from left to right created in a specific architecture. I would just point to it. When you start an architecture, you always need, of course, some kind of hardware, but we don't standardize this in Autosar. We rely on a so-called POSIX standard, PSE51, that's a subset of it, a set of interfaces, which is also compatible with a lot of POSIX supporting systems. You might know, now I need to be careful with products to mention, but there are some operating systems that already provide a kind of criticality that you really need. I think Linux is something we could think of, but we haven't seen Linux running for ASIL related applications only. So it's usually built something on top. And then you ask yourself, how can I spawn a process? How can you start a scheduler? You start going to the top, you create an execution management, then you start to do a communication, you go to the left side, you pick a protocol you like. That's for us SAM-IP, and for others maybe DDS. You create a basic communication over Ethernet, and then you have a base standard types you can really reuse from the standard, and go to the right side where you have a plenty of automotive specific features. And this is also the benefit of Autosar. We have automotive software experts that are really inside of this ecosystem for years. So they know the ISO, related ISO for diagnostics, for time synchronization, it's IEEE, for for the platform health management is, of course, the ISO 26262, where we have a kind of watchdog, platform health monitoring possibilities. Identity access management is something very important for security, when you need to grant access for a file system. And then you go to the right, you need, of course, a kind of debug possibility for your data, which we're widely used is at the moment DLT from open source communities reworked. And cryptographic libraries are quite common, and I think this is one of the future standardization purpose we have as a common challenge. So we need the companies from the security area, from the banking fields, from where IT is really longer already in place, that we can trust them. So, and there we can gain the experience combining it with the security needs of automotive. You maybe ask yourself, where's the difference between gray and blue? That's the frequently asked question on this slide. We have the ARA adaptive application. ARA is the middleware, and ARA.com is collecting all the services that are provided for the applications on top. You build here on top your application. It could be something for lane detection, for example, or something easier for body domain use cases, which is already implemented on other platforms. And then you connect it to a service provided by ARA.com, which could be from the area of diagnostics, network management, or update and configuration management. Or you bind it to a kind of library that can be used as an API here from the left side from another library for security or for safety, for example. So this is somehow the architecture, what you need to understand before setting up a platform. And this was really like in 4 or 5 minutes, and I hope it's deeper to understand, I think, in reading out specification, in looking on the demonstrator. We provide from the standard also code. I will dig deeper a little bit in the security and the safety area. I would start with the safety part because it's an older topic for automotive, and I think we can tell here more. When we ask ourselves what are the use cases for such a platform, it's definitely one use case to go in the automotive driving area. So we split here the offboard and the onboard systems, and partly the processing power is distributed to systems we don't even see. We have to deal with services that are coming from another dimension we don't see. So, but what we can definitely steer is on the left side, the perception or the trajectory planning. Those are typical applications for such an adaptive platform. And in between there are some phrases which are saying safety and security is really demanding for these use cases. On the one side you get updates which must be secure, and on the other side safety and security in onboard system is something you must monitor. And this is something how you can gain trust. I always hear people talking about safety and they say the word trust in the same sentence, but nobody can really answer what makes us a system trustworthy. And I think there's a gap of implementation and industrialization provide trustworthy systems. So we try to find an answer on that. How can we do that? So if we talk about trust, it's always somehow a system in background. And the most complex system, to be honest, I know is the human being, and because we can explain ourselves. And when you have to trust another human being, you ask yourself, is the person reliable? What means reliability for us? It's split somehow to 4 aspects. The one thing, you feel secure. If someone stands beside you who gives you the feeling to be secure. as a system. Let's point out a human being is a complex system. On the other side, you feel safe yourself in the same time if you prepared yourself to be safe. And the availability is the precondition for all of it. It's somehow your health. Because if you are not healthy, you're not even there. From my perspective, the availability is the first thing we need to take care of before looking on safety, security, and our intelligence, which is based on know-how and maybe on experience. So that's a human being kind of, and if all these four factors are kind of complete, we feel ourselves like trusted and secure maybe a little bit more. So let's point out a little bit more in the topics of availability. I mentioned the topic of health. For me, it's we can't do anything of these things like being secure and safe if we are not available at all, if we are not healthy, if we have a flu, we get a medication, we are degrading somehow. And if we even are more influenced by that, we have to go to the hospital. That's our safe state, in fact. You feel safe there, right? So at least nothing can happen to you. There's a doctor who's watching you. He's your platform health monitor somehow. On the secure side, you can also have the same thinking. Where do you feel best secure way? It's when you cut yourself outside from outside. It's maybe the prison. Maybe it's also unsecure in some ways, but inside of prison you have some walls around you. You don't interact at all, so you can, or you know your risk very early. This is the other possibility. That's the two possibilities you have as a human being to feel more secure. How can we kind of move that to the system approach? If we think of two processes that are interacting, they have maybe a sensor, they get information, they act on a specific thing, and have an actor in behind. And also those systems are having this difficulty to understand in which state are we at the moment moving. So I called this slide from fail safe to fail operational, because in safety we are quite good in being fail safe. I remember my times in serious projects, the best way to be on the safe side is just to decrease the acceleration and just to brake. And then you can do almost anything, right? But the point is the state in between. When we're degrading, there are a lot of steps in between. And the only possibility to identify that is to have a health indicator. So to say you are in a specific intermediate step that you can act on a drive, a comfort way, or in a safe or stop. So you're degrading in your system behavior. That's where I jump now more to the Autosar specification, because we talk about health channels in platform health management. We have seen this architecture picture before. I tried to explain it in 5 minutes. I hope you somehow get it. And then the safety parts, just with a kind of rectangle with a transparent one. And the platform health management is something which with the function cluster we observe the health of the whole system. So you get health indicators from different directions. Why are the other parts interesting for safety? I just sum it up. You need to schedule. That's always safety related. You need to communicate end-to-end protection. I mean, all of you need have maybe seen the different profiles we have in Autosar Classic. And time synchronization, as I mentioned, the Ethernet communication is not bound to time at the moment. It's packaged, and then you have to get a kind of library to start counting. And it must be a safe time, a synchronized safe time. The crypto library is somehow a good example because the topic of software robustness is handled in both areas. We need a robust software. It means a lot of background, how we test it, how we provide coding guidelines, what kind of coding features do we really use, exception handling or not. So both aspects like safety and security are, with these demands, similar. And if you go on the right side, you need to know your safe state. Of course, your sensors must be safe, and your update and configuration management shouldn't split too much or touch too much your safety parts, because if you need to update them. So somehow this is very crucial, because if we need to be flexible, you get in one point in time to the situation that you touch an ASIL B software component, which is certified before going to serious, and you don't want to touch it too much. So this is the difficulty in the update process at all. We are now in the step where it's going to be a little bit more detailed in the sense of architecture. The PHM I mentioned before is somehow the monitoring module of the whole safety system, where we also can indicate health, where we can have different approaches to supervise the application. I just explained the left side, it's the outside architecture, and then the right side is how a PHM is working. So the Platform Health Manager has connections, monitors the state manager, it monitors the application, and it demands a recovery action from the execution management. In case I degrade, I need to know what kind of recovery I can get. So maybe there is a function I can even call in case I'm in the specific mode, or I have a return value that is bound already or is static. This is a recovery action. This is somehow how we look from outside to the Platform Health Manager. The Platform Health Manager inside has different supervision possibilities: logical, alive supervision, and deadline supervision. Logical means it's like a scheduler in the past. You know which step comes after another, and you supervise that from different checkpoints. It's going too deep? It's okay? Okay. And then you have alive and deadline, which is more time-based. Means you calculate your time base, and then you ask yourself, get I a response on the alive or not? And I can do that once, two times, three times, and then I have also recovery action. So somehow it gives you the possibility to measure the way the health indicator can be observed. And the more health indicators you get, the better you are. So let's point maybe an example that's easier. You have this person, complex system, sitting inside a car, and he was with his friends outside. He had a beer and maybe two. And after that, you see that in your inside camera in his eyes. So maybe the health indicator of this person is not that good. You can compare that to the health indicator of your ECU and say, maybe we should go for another profile inside of our car, because this guy shouldn't drive at all. So we can combine health indicators if we look outside of our ECU systems in future. And this makes us more safe if we go for automated driving from my perspective. As I mentioned before, there is alive, logical, and deadline. And there is an example how it could look like in code. So we have checkpoints to kind of access that from the application. You can log against it, you can implement against the checkpoints, and it's definitely extendable. On the right side, you see how the supervision really works. And it's a local supervision, a global supervision where we could think of a system. And the local supervision is really bound to logical supervision that are connecting checkpoints. And checkpoints are really seen in the code. So this is somehow the internal behavior of the PHM. This is the deepest level I would go today. I hope it gives you a little bit more understanding on that. We'll go back to the security bridge. I marked it yellow, and you see that there's some overlap because in the safety area we kind of marked similar parts on the left side, and the security is providing us two possible function clusters. The one is very extensive, that's the crypto API at the moment, and because it combines a lot of aspects and a lot of requirements from security region. And the second part is bound to the crypto API really much. On the right side, only diagnostics is different because security and service diagnostics are very connected. So if you bring your car to the dealer, you must have a basic diagnostics with a good security possibility to not interfere here from outside. So this is the only difference for safety. On safety level, you really say diagnostic and safety are not really connected to each other from the current point of view. And if you look on the requirements we found in the standardization, that's the left part, there are definitely directions for date and time. I'm starting from the lower part. Software robustness we talked already about, the date and time. Onboard communication, you must have a secure onboard communication for signal-based, but only also for services. And of course, certificates, keys, there's a major, I think, demands from the security area. And I think there are standards from the IT technologies which can be reused here. Secure modes, the state manager we have in Autosar must be secure, that you don't interfere as well in this direction. And the diagnostics I mentioned before, and privacy protection is something like the access management of specific roles, rights to overwrite things on the file system or not. So these were the basic things we could handle in the standardization. A security management system within an OEM or supplier has much more requirements. So we see also something which is going to really to build up a car. You don't get this done inside of the standard because everybody here is kind of different. So there, you need to draw a line somewhere. What efforts you do in the standard, in the community, and what parts you really demand from serious development. And for us, the crypto service manager is a central topic. We are working in standardization here for 2 years now. And we are combining here requirements coming from outside to typical automotive use cases. And it's really hard. So everyone who have seen the SEC group in Autosar working, it's sometimes fun watching, but it's not fun participating in really getting output out of a meeting because there are so different opinions at the moment. On the other side, it's also challenging because we are driving things that might be referenced in a lot of serious development, and we can't wait. We can't wait for another standard here. We use the state of technology to reuse it for our series. We can't wait here for another long-term standard. The API on top is for the application developers. It must be lean. And this is the real difficulty in the crypto API because the subset of features, and that's a colorful picture I reused from the group itself, is really a package. The specification itself right now has more than 200 to 300 pages. It combines a lot of requirements which we saw on the page before. And for us, the application, the adaptive application, would need a lean API, which kind of need also an inheritance behavior on the API side to provide all these features which you need in the isolated and trusted environment. Because those are, you remember the prison, the isolated environment, you feel secure in this phase. And if you get features to make you even more secure with certificates and really approved keys, you trust there on this level. And that's the real challenge here, to provide these guys the adaptive applications, an API which is lean, but on the other hand also complex and providing the state-of-the-art security features. So everybody who is really into security in this room, or maybe outside, you are invited to join this group. It would make it bigger and maybe worse to standardize, but but we would need your feedback, and we really need your expertise on that to a little bit accelerate the automotive ideas here. What's the difference in security? Because everybody is talking also about it, and Autosar is providing you here already a part of an implementation, which is an API in future. And this is, for me right now, more helpful than discussing the processes and about the risks we don't even know. Starting with a measure in this way is giving you much more than just thinking about future and assuming what risks might come up and do I feel secure in my prison, or should I maybe create some nice windows on my walls and then they can see through it, and I feel maybe unsecure, but I can also put some surveillance cameras outside and can observe them. And if I react in a good point in time, I maybe also feel more secure. So there are different ways to react on things. You don't have to build the biggest wall around you to feel secure. That's my point. 2 more slides to the organization. Autosar is working in releases. We release yearly, starting with this one in November. We are in a hot phase at the moment. Last change requests coming in. We have classic, adaptive, and foundation. Foundation are protocols we can reuse for our other systems. If you feel one time the standardization work, that's why I like it. It has a lot of aspects that you don't see in your usual work, which you know from your own company, because you get different cultures on one table, on one technology, with one frame, all compliance-wise fine. This is also something very special. Not everyone can say that. And you can work on real technologies. This is the organization. I will just jump over that. We put safety and security in a really leading position. That's one of our pillars of our organization. They are reviewing almost every change request we get. You didn't say about the content, how much I have to present. So the last slide I will really show is if you would really get a nice impression about the whole community, what we are doing, about partners that are presenting the state-of-the-art challenges. We have a nice event that's planned for start of March. It's in Lisbon, and we have a nice site there as well in the Nova University. We will talk about adaptive, about classic. There is a demonstrator running with a Pi car, which is kind of line detection of a Python-based car that where adaptive is running on it, and it's coming with the code, which is with the demonstrator. So I really would appreciate to maybe see some of your faces, there, and yeah, this would be my end of the presentation. I hope I gave you a little bit of a snapshot what for standardization means. Not only saying safety, security, and trustworthy. For Autosar, it means to provide an API that brings you into the industrialization part, really using it. It's my faith.
In this podcast show, we bring in the industry leaders and experts in the automotive domain to share their experiences along their journey. The mission of our podcast is to start a dialogue that will allow us to understand the development of automotive industry and where the automotive industry is going. You can ask questions to our guests directly. Just send us an email to podcast
info@matrix.de. We'll schedule a call with you during the recording and you'll be part of our show. Make sure you subscribe so that you don't miss any new episodes. Please share this video to help others get enlightened as well, and that would mean a great deal to us. See you in the next episode.